Okay, let's go ahead and tackle another one. So, let's see here. We want to find the area of the surface generated by revolving some curve around the x-axis again. So this is a little bit harder than the last one. Let's get a good sketch out here. Okay, so what we need to know is, what does this guy look like? Okay, so I'm just going to go ahead and grab a graph here. Okay, so we've got the square root of 2x minus x squared. Okay, so there that guy is, right? So we've got this semicircle, and what we want to do is we want to take this guy, oops, and we want to rotate him about the axis from 0.5 to 1.5. So let me do the following. Let's grab this guy right here. Okay, so there he is. Okay, now what I want to do, I want to go from 0.5 to 1.5. So that means from here to here. Take this guy in here and revolve it, right? Well, I shouldn't say in here. I should have drawn it like that. I want to take this top guy right here and revolve it. So this is what's going to revolve around. It's going to generate some kind of surface area. And if you think about what that's going to look like, it should look like kind of the shell of a sphere. Okay, we should have some kind of shell-looking piece there, right? Okay, so you can kind of imagine what that would entail. Okay, so I don't even have to draw it out over here. Now, what we need to do is, since we're revolving around this axis, we need to have the formula set up for it, and we've already derived the formula, so we know that the formula is 2 pi, okay, times the function times the square root of 1 plus the derivative of the function squared dx. And we should always, again, make sure that our formula is written out correct, so let's go ahead and check our formula. Okay, so it's 2 pi function square root 1 plus the derivative squared dx. I believe that's exactly what we've got. Now, we're going from 0.5 to 1.5, like that. Now, what we need to do is we need to find a formula for the derivative. Okay, so we've got that, and we've got our function. So we'll go ahead and we'll plug that guy in there. Okay, then we've also got another square root of 1 plus. Now, what's the derivative? So what we're going to do is we're going to use our chain rule here, right? I'm going to write it all out, so don't do it in your head. So let's let u be equal to 2x minus x squared. Okay, then what we have is we've got the square root of u, but we want to do dx of the square root of u, right? We want to take the derivative of this guy with respect to x, so that's what we're going to do. But in order to do this, we have to use our chain rule here, so this is du dx times du of the square root of u. Okay, so what is du dx? Well, du dx is the derivative of this guy, so it's 2 minus 2x. Like that. And the derivative of the square root of u with respect to u is just going to be 1 over 2 square roots of u. So this will be 2 minus 2x over 2 times the square root of u, and u is 2x minus x squared. Okay, so that ugly mess has got to go in here. So let's go ahead and plug it in here. So this is 2 minus 2x over 2 times the square root of 2x minus x squared dx. Let's see if we can simplify this a little bit. First, these 2's, they cancel out. Okay, so we've got 2 times pi from 0.5 to 1.5. 2x minus x squared. Oops, sorry, forgot to square this guy. Okay, but it's still going to cancel that stuff out, okay, as we go through here. So this is going to be the square root of 1 plus, now this is going to be 1 minus x over the square root of 2x squared minus x squared squared. Okay. So this will be 2 pi times the integral from 0.5 to 1.5. See if we can simplify this a little bit more. So I've got 2x minus x squared times the square root of, now this is going to be 1 plus 1 minus x squared over 2x squared minus x squared, like that, right? Square and the square root cancel each other is, well, it should be the absolute value of this. It's not 2x squared, it's 2x. I don't know where that guy came from. We don't want him there, right? Okay, so so what's the deal with this? Let's just make sure that this is positive here, okay? So as x varies from 0.5 to 1.5, okay, so what I need to do is I need to check to see if 2x minus x squared is positive over that range. So what I'm going to do is I'm going to go back here and I'm going to test 2x minus x squared, but notice that it has to be positive over that range because it was part of this underneath piece, right? This, okay, was the part underneath here, so of course it had to be at least 0 or positive. So what we've written here is correct, okay? So this is going to be 2 pi times the integral from 0.5 to 1.5. And this is where you start to get tired as far as trying to do all this stuff out. Okay, so I totally understand that. So this is going to be 2x minus x squared plus, plus 1 minus 2x plus x squared over 2x minus x squared. So let's keep going here, see if we can. Now, it may be the case that I should have done a trick earlier. Okay, that's very possible. But you let it go, okay? You just keep working through. Actually, I see a trick that would have been faster. Oh, but it's going to be all right. Okay, so watch. See this guy? When I multiply, if I have the square root of a times the square root of b, well, that's the square root of a times b, right? So this is equal to the square root of 2x minus x squared over 1 times 2x minus x squared plus 1 minus 2x plus x squared over 2x minus x squared. Those guys are gone. Now, the thing is that 2x minus x squared can't be equal to 0 because it's in the denominator here, but that's not an issue. Okay, think about why that's not an issue up here. Okay, so let me scroll down a little bit, get some room here. So what have we got? Well, we've got 2 pi times the integral from 0.5 to 1.5. I keep forgetting my dx's out here, huh? Okay, so what's left? Well, we just have this guy on the inside. So does anything cancel? Well, the x squareds can go away. These guys can go away. I'm just left with 1. That seems too easy, huh? Maybe I did something wrong, maybe I didn't. We'll check it out. Square root of 1 is just 1, right? Okay, so this is working out pretty nice. This is 2 pi times x evaluated between 0.5 and 1.5 to pi. Okay, so this is 2 pi times 1.5, which is 3/2. Okay, minus 2 pi times 1/2. So these cancel out, and so this is 3 pi minus pi, which gives me just 2 pi. So let's go ahead and check that guy out and see if I got it right. And we're good. Okay. So the thing is just, guys, I don't work any of these problems ahead of time. I just try them and see how they go. And sometimes you make mistakes. Sometimes you find ways that are faster than other ways. But the important thing here is what you'll notice is you just stay consistent. Just keep working. Okay, don't give up on the problems.